Hey everybody, this is Larry. This is day 12. I don't know why I struggled with that one. Well, hit the like button, subscribe button, join me in Discord, let me know what you think about today's poem. I just finished after a shower, of course, my 16-mile run. I always forget what that is. Okay, was that 26 kilometers almost? So I am just tired. Like it wasn't effortful, but it's just long. So I was just a little bit tired out. So hopefully today's video will still be okay. So let's take a look. Without further ado, we'll save the chat for when have a little bit more energy. Let's take a look. We have 3227 Vowels games in a string. Okay, Alice and Bobs are playing a game on a string. Okay, they take turn. Alice goes first. Has to remove any non-empty string S that contains an odd number of vowels. On Bob's turn, any non-empty substring that has even number of vowels. Okay, so I think the first thing to note is that I want to say it doesn't, the consonants don't matter, but that's not quite precise. That's why I took a pause, because I was like, it kind of does and doesn't, right? I think there is like a very easy strategy, maybe, right? So cannot make a move, right? So on Bob's turn, Bob can always make a move, I think, unless there's literally only one vowel left, right? Because you can always take 0 vowels or 2 and then kind of squeeze it in. So maybe that's a little bit tricky. Maybe I'm not quite, well, Bob can make a move. It might just not be a good move per se, because you could just take a consonant with 0 vowels, right? Alice will always have to take 1 or 3. What is the strategy here? I think this is one of those problems that is just strategy, right? Or how do they call it? Constructive algorithms. So basically you kind of have an answer by proof or either by induction and kind of work it out or something like that, right? N is 10 to the 5th, which is pretty big. That means you don't have to think about n squared type thing. So it's not like dynamic programming, for example. That means that in a cheating kind of way, not cheating, just meta thinking kind of way, it's probably dynamic. Oh, sorry. It's probably some sort of greedy / strategy thing, right? Okay. Well, so it turns out that if the string is empty, the other player loses. So okay, so if the starting string has only one vowel, then Alice goes first. Alice just takes everything, one or odd number, right? So then if so that's kind of the base case almost, right? So if the beginning there are odd number of vowels, then Alice just wins, right? That's one. So what if it has even number of vowels? Even number of vowels means that obviously if it has even number of vowels, after Alice's turn has odd number of vowels, right? Well, what does that mean? That means that whatever Bob does, there will still be odd number of vowels left, and then Alice can go and then win, right? So that means that it almost feels like okay. Let me write this down because I feel like I have to make sure I am consistent, right? So if initial string has odd number of vowels, and honestly, I don't know that there's any algorithm here. It's just pure thinking through all the cases, maybe, right? Then Alice wins by taking everything, right? Okay, so then now the other case. So else even number of vowels. Alice takes odd number of vowels, so there will be odd number of vowels left. So that means that Bob cannot win because Bob cannot take everything, right? And there's at least one wow left because there's always going to be odd number left, right? Cannot win and takes even number of wows, and then Alice takes everything else since there are odd number of wows, so Alice wins. Obviously, this isn't quite true, so I feel like I'm missing a case because of this thing. Oh, I see. Because I didn't look at the case, I just saw that there's force. So basically, yeah, I mean, if you can't take even one wow, then you lose. And I guess that's it, right? So that means that, yeah, for C in A, E, I, O, U, if C is an S, then return true because Alice wins. If none of them are happening, then Alice cannot go the first turn, and that's it, I think. Right? Okay. I mean, pretty silly problem, honestly, but... And also, honestly, if I wasn't... if I did the same thing, right? Yeah. And also, honestly, if I wasn't, like, so tired running 16 miles and it's 2 a.m. now, I probably would have done another bonus problem, but I just want to go to bed. My legs are barely moving, so yeah. But yeah, this is obviously going to be linear time, right? We have 5 characters, we just do a linear scan. You can do this in other ways, but it's all going to be roughly the same, maybe. I mean, you could do a lookup. Maybe it's a slightly faster ways, but yeah, I mean, obviously the code isn't the interesting or the hard part here. It's kind of our analysis, right? And also, kind of example 2 gave it away. I don't know if I would gotten it wrong, because I would have to think through like where Alice loses, which is in this quad. I mean, you know, it's kind of one of those things that is obvious when you kind of point it out, especially obvious when you point it out. But I don't know if I would have gotten it without noticing example 2 immediately. Though I would have, I mean, it would have been just weird to just return true no matter what. So I would have like maybe gave it a little bit dark, but this kind of gave away the game a little bit, and everything else is proof, right? So I don't know. Yeah. Anyway, that is all I have for this one. Let me know what you think. Thanks for watching, and yeah, go sleep. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.